In school, we have learned that all objects are made up of fundamental particles called atoms. For instance, this water is made up of hydrogen and oxygen atoms, or as we commonly know it, H2O. I know that many of you have already seen an image of an exoplanet or a nebula. These objects are found in outer space and they are extremely far away from us. If that's the case, then how are we able to know that this planet's atmosphere is made up of hydrogen and oxygen if we cannot even go there? Surprisingly, determining what these objects are made of is a clever trick that uses light.
I am Marco Sagun.
I am Amy Manuel.
And I'm Carlos Doctolero. We are from Philippine Science High School, Ilocos Region Campus, and we will be competing in the C2 category of the AFC 2021. In this video, we will discuss the principle of spectroscopy.
To construct your CD spectroscope, you'll need a cardboard tube and a blank CD arranged like this, an electrical tape, a 12-inch ruler, protractor, and a pair of scissors which has a pointy edge, so make sure an adult is supervising you.
Now, try to point your spectroscope to a light bulb. What do you see? You see a band consisting of all colors. That's because white light is just a combination of all colors of light.
When light from a source hits the CD, its different component wavelengths or colors are spread at different angles since the CD would act as a reflection grating due to the presence of the small pits. The more reddish light is reflected at larger angles, while the bluish light is reflected at smaller angles.
Well, what does this have to do with stars?
The key here is in the different colors of light. When white light passes through a planet's atmosphere, the energy carried by the light is absorbed by the electrons of the atoms that make up the atmosphere. But here's the catch. Electrons are quite choosy since they only absorb and emit specific colors of light. For instance, the electron in the hydrogen atom only absorb and emit specific shades of red, sky blue, blue, and violet light. Therefore, when we let light pass through an object that contains hydrogen, these colors will be missing in the spectrum. If the light that passes through that object does not contain these colors, then simply hydrogen does not absorb it. Each element has their own unique preferences. Essentially, the different colors of light that a compound has absorbed serves as its fingerprint. If we can identify these colors, then we will know the chemical composition of that object. And to do this, we use the spectroscope.
When we point our spectroscope to this yellow flame, we would see that the light it gives off is mostly made up of yellow light.
When we look at the specific wavelengths of these colors, we would actually see that these are the wavelengths that sodium absorbs and emits.
Therefore, when we look at the spectrum of light that passes through, say, a cosmic dust, and the yellow colors in the corresponding wavelengths that we observed are missing, then we can say that the cosmic dust from which the light has passed through contains sodium.
Although the spectroscope that we have here cannot be used to determine the composition of stars and nebulae, actual spectroscopes that use highly advanced mechanisms actually have the same founding principle: spectroscopy. Nonetheless, it really is fascinating how we can identify the composition of cosmic objects using their emitted light without even getting near them. But do you know what else is fascinating? Is the fact that even though we humans are microscopic in the cosmic scale, we have the ability to probe even the largest of objects. Indeed, as Neil deGrasse Tyson said, we are stardust brought to life, then empowered by the universe to figure itself out.